Hi everyone. In this tutorial we will talk about the numerical methods and we will concentrating on the bisection method. So what are the numerical methods? When analytical method does not work because of their limitations, so then we have to go to the numerical methods for the solution. Suppose we have an equations and we want to solve for y. Suppose we have a function f of x is equal to y, and now if I draw a vertical line and horizontal line, and I suppose it is my y and this is my x, and my equation occurs like this. So as you can see that we need to find this value. This is basically called a root of the equation. I want to find the f of x equals 0. Solve for x means I need to find the value at which the function of x is 0, y is 0. So how we will find this value? I will find this value if I have any value above this x-axis. X, suppose this is my x1 and I have another value. Let's suppose that this is x2, and if in this case my f of x1 is positive and my f of x2 is negative. If I want to calculate this point, then my first best approximation will be to have x is equal to x1 plus x2 divided by 2, and the function at x prime will be positive or negative. So this means that our root is always lies between the positive and negative number. So let us solve an example to analyze this method, how we use bisection method to take out the roots of any equation. Let's suppose we have an equation, nonlinear equation, f of x is equal to x cube minus 4x minus 9. And let's suppose we choose two initial guess values, in which at one value the function is positive and another value the function is negative. The at 2 function will have a negative, and f3 and 3 function will have a positive sign. So my first approximation will be x1 plus is equal to half 2 plus 3 is equal to 2.5. Add function 2.5, the answer come out minus 3.375. It's a negative number. Then we go to the further for second approximation. So for second approximation we will choose two values in which one will be positive and one will be negative. So this root is come out negative, and I choose another value which should have two positive. So I choose one value is x1, another value is 3. So my second approximation will be x2 is equal to half x1 plus 3 is equals 2.75. At 2.75 function will have a positive sign again. It have a positive sign. Then I go to my third approximation, which is x3 and x3. So let us see that we can see that x2 will have positive sign and x1 will have a negative sign. Then I choose these two values for my third approximation. X is equal to half times x1 plus x2, and the answer comes out 2.625. At f of x3 the function will have again a negative sign. So as you can see that we try to go as close to the 0 value of x which gives a function 0. So Again we do the same thing for my fourth iteration, and my fourth iteration is half time x2 plus x3, and my fourth root will be 2.6875. At function at f of x 2.6875, function come out negative sign, which is 0.33911. As we can see that as we go further and further and do more iteration, we try to go closer to 0. So we do 2 or more 3 iteration for to get a 0, to get a value at which function 0. So x5 is equal to x half time 2.71, which is I think is x1 or x2, and plus 2.675. It's come out my fifth root, which is 2.7189, and f of 2.7189 is equal to positive. It's much lesser than this value. So we try to go to closer to 0, and we do one more iteration. x6 is equal to half time 2.7189 plus 2.6875 is equal to 2.7032, and at 2.7032 function will have a negative sign, but it is more closer to 0. So we try one more iteration. We choose two values which at one value function have negative sign, and another value which have function has positive sign. So x7 will be equal to half time 2.7032 plus 2.7189 equals to 2.71105. We will have to check at this value what will the function have positive sign or a negative sign. So again function gave it positive sign, but is more closer to our achieve our goal, which so we try to closer to our root, and so this way we use we try to closer to our root, and this is a bisection method. And this bisection method does not use for any type of equation. This is but for this particular equation, this is best method. And so thank you very much.